Welcome back to First Principles Daily, episode 38. Starting the week by asking what things should actually cost. A routine dental filling can cost hundreds, while the materials inside are worth only a few dollars, showing where the real price drivers sit. Consider a dental crown that reaches the patient at roughly $1,000. Inside that crown sits metal or ceramic stock worth perhaps $20 once the atoms are arranged. The difference does not come from exotic elements or scarce minerals. Instead, it accumulates through the sequence of appointments, the specialized labor in each chair, the small practice overhead, and the regulatory scaffolding that surrounds every step. That gap is the opening the show will examine today. Dental work still follows a model built around the solo or small group practice that emerged decades ago. A patient typically books an exam, returns for preparation, and returns again for seating. Each visit consumes chair time from a clinician whose training spans 4 years of dental school plus residency. Most offices maintain their own imaging equipment, sterilization suites, and billing staff because referral networks remain limited. Insurance reimbursement schedules and state-by-state licensing rules further lock the pattern in place, so the same procedure is repriced rather than redesigned. A composite filling, for example, is placed by hand under magnification with incremental curing and polishing that can occupy 30 to 40 minutes of the dentist's time. Crowns follow a similar path. An impression or scan leads to an off-site lab that fabricates the restoration over days or weeks, after which the patient returns for try-in and adjustment. These steps feel normal inside the profession because each one was added incrementally to solve yesterday's problems of fit, infection control, or liability. The cumulative effect is that the delivered price reflects accumulated labor hours, facility costs, and administrative layers far more than the physical contents of the restoration itself. Prevention programs exist but rarely scale to the point where they shrink the overall volume of restorative work enough to change practice economics. As a result, the current price structure continues to appear inevitable to those working within it. One objection often raised is that each added visit improves diagnostic certainty or reduces error rates. Yet the data on multi-visit versus single-visit protocols show that the incremental benefit plateaus once basic imaging and isolation standards are met. Another entrenched factor is the capital tied up in underutilized equipment. A practice that owns a cone beam scanner may spread its depreciation across fewer procedures than a high-volume clinic would, raising the per-case overhead even when the scan itself takes only seconds. Billing layers compound the total because each claim must navigate payer-specific coding, prior authorization steps, and denial appeals that can consume staff hours equal to the clinical time itself. These frictions are rarely questioned inside the system because every participant optimized for the constraints visible at the time, rather than for the physics of the tooth or the commodity price of the restorative material. If a magic wand could assemble the finished restoration from raw atoms at commodity prices, the floor would be set by the actual materials. A typical amalgam or resin composite filling uses on the order of a gram or 2 of alloy or filled polymer, whose commodity value sits in the low single-digit dollars. Even a full ceramic crown draws from perhaps $10 to $20 of zirconia or lithium disilicate blank. Once the blank itself is priced at scale, adding the cost of local anesthetic, a few cotton rolls, and a matrix band still keeps the rough total under $20 in most cases. Against a delivered fee that commonly ranges from $200 to $500 for the filling and $800 to $1,500 for the crown, the implied idiot index lands somewhere between 10 and 75. That ratio is only an estimate because exact material invoices vary by supplier and volume. Yet the order of magnitude is consistent with published dental supply catalogs and procedure fee surveys. The gap does not sit inside the filling material. It sits in the sequence that surrounds it. Chairside time from a highly trained dentist accounts for the largest single slice, followed by the fixed costs of the operatory, the staff required for scheduling and claims, and the carrying cost of the multi-visit workflow. Digital impression systems and in-office mills can compress some of those steps, yet adoption remains uneven because capital outlay and training requirements favor larger practices. Fragmented ownership also prevents the volume purchasing and standardized protocols that would otherwise drive the per-unit overhead down. Each of these layers adds to the finished price without changing the atoms inside the tooth. To see the arithmetic more clearly, consider a zirconia crown. The blank may cost $12 at wholesale. The milling burr set adds another $3 amortized across uses. The sintering furnace electricity perhaps $1 per part. Even generous allowances for scrap and quality rejects keep the physical inputs below $25. The remaining $900 or more therefore trace to the dentist's preparation appointment, the lab technician's design time, or the in-office mill operator's supervision, the second seating visit, and the practice's rent, insurance, and compliance overhead spread across the case. One common objection is that material prices themselves fluctuate or that premium blanks carry hidden quality premiums. Yet even doubling the blank cost to $40 changes the idiot index only from roughly 40 to roughly 25, still leaving the dominant share of the price outside the atoms. Another objection holds that patient-specific anatomy requires custom labor that cannot be standardized. The counter-observation is that once a digital scan exists, the geometric variability is captured in software parameters rather than in additional physical labor hours, which is why centralized milling centers already demonstrate lower unit costs when volume justifies the capital. A redesign would begin by shifting routine preventative and simple restorative tasks to hygienists and therapists operating under clearer protocols, which several jurisdictions already allow at pilot scale. That single move reduces the minutes a dentist must spend per patient, and thereby lowers the dominant labor cost. Prevention that actually reaches daily brushing, flossing, and fluoride regimens at population level would shrink total demand. The arithmetic is straightforward because each avoided filling removes both the material and the entire service chain around it. Standardized intraoral imaging combined with teledentistry review could triage cases so that only those needing physical intervention reach a chair, cutting unnecessary visits. Digital fabrication offers a third lever. Once a crown or a liner is designed from a scan, additive or subtractive manufacturing at centralized facilities can produce the part overnight at a fraction of traditional lab cost, provided regulatory pathways treat the file transfer as equivalent to a physical impression. Each of these changes requires concrete conditions, expanded scope of practice statutes, interoperable scan formats, and liability frameworks that assign responsibility clearly before the cost can move toward the material floor. Safety and outcome data must remain the gate. No redesign can bypass controlled trials that demonstrate equivalent or better longevity and lower complication rates. The hard limits are therefore not the physics of the materials, but the licensing, training, and evidence thresholds that correctly protect patients while still allowing process innovation. A further objection is that shifting tasks risks missing subtle pathology. The practical response is staged oversight, where the first several hundred cases under new protocols are double reviewed, after which statistical monitoring replaces constant direct supervision, exactly as has occurred in other fields when diagnostic algorithms matured. Another constraint is capital concentration. Centralized mills require predictable case volume, which fragmented practices cannot guarantee, so the first adopters are likely to be dental service organizations already operating dozens of locations. Policy changes that permit cross-state teledentistry review would further enlarge the addressable volume and thereby justify the capital outlay sooner. One principle is that when clinician minutes dominate the bill, any safe transfer of tasks to less specialized operators immediately changes the arithmetic of the entire service. A second principle is that prevention and digital standardization attack demand and fabrication cost at once, rather than merely trimming the price of an unchanged workflow. The open question is which dental service organization or regulatory body will publish the first controlled dataset showing both lower total cost and maintained clinical outcomes after these shifts are implemented at scale. That's First Principles Daily for today. If this changed how you see what things cost, share it with someone who'd appreciate it, and subscribe wherever you listen. I'm Patrick in Vancouver. One example or one opportunity every day. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at Nerra Network. Links in the show notes. And before you go, this show is part of the Nerra Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Environmental Intelligence, the Environment and Climate Policy Brief for Canada. Find every show free at narranetwork.com. And on the website, every episode's visuals live in our free image gallery at narranetwork.com/gallery. Royalty free under Creative Commons, download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own. I'm about to prove